Hello and welcome back. Today we're going to take a look at how you can utilize operator overloading within C#. What exactly is operator overloading? Well, operator overloading permits user-defined operator implementations to be specified for operations where one or both of the operands are of user-defined classes or structures. Basically, operating overloading allows you the ability to create your own operations that can be performed on a class. If you've done any .NET coding, you've undoubtedly seen operators and how they've been used within the framework natively. Some examples of those would be, the plus, the minus, the multiply, the divide, ampersand, percent. We've seen all these. We've also seen and not equals to, and the plus plus, and the less than and greater than, a whole slew of things. And within .NET, a lot of objects already have these provided to them. For example, integers have the ability to add and subtract each other and decide if one's less than the other. But you can also apply these operands to your own classes. And this can be pretty useful and pretty powerful in various different circumstances. It depends on your need. In our example today, we're going to look at two of them. We're going to look at how you can create a equals or not equals to operand, as well as a less than or greater than operand on classes in order to do some simple comparisons. So what are we going to do first? First, let's go ahead and create a class. We're going to call this a player. Let's move this to its own file real quick. Our player is going to have a first name, last name, and an age. This is going to be important here in a second, especially the age, because we'll use that to do our greater than or less than comparison. And I'm going to go ahead and create a constructor on it. Nothing major. Now, I've created a basic player with no operator overloads. So what I want to do first is create a unit test that will show how this will actually work. So let's go ahead and create a new player. We'll call this Hank. And Hank Aaron is 75. Call him an old-time player. And we'll go ahead and do the same thing for Lee. Mays. Call this another old-time player. And I've created two players. Now what I want to do is I want to see, can I test that they're equal to each other? So let's do debug.writeLine. Are players equal? Now, without doing anything, I can actually still do equal, equal, or not equal to. But it's not going to quite work the way I expect it to. In fact, let's do this. Let's create it where I say, is old-time player equal to old-time player, and old-time player equal to another old-time player. And actually, let's create one more here to kind of give you a full example. So I have three tests here to evaluate whether. So let's run through this real quick. Now, if you look down here at my output, you'll see that the first one shows up as equal, and the second and third show up as not equal. Well, that technically is true because by default, the equal operator will check references of the two and see if they're the same references. In my first example, they are. They're the exact same instance. Now, my second, technically they're the same value, right? Hank, Aaron, first and last name are the same, and the age is 75. But they're not the same memory reference, so it evaluates as false. The third is clearly different because in our example here, again, it's not the same memory reference. But what if I want to change it so that I look at things other than just pure memory references? To do that, you can do it pretty easily. So let's go ahead and create your operator. You just create a public static class, and we're going to have this as a return type of Boolean because it's a binary operator. I'm going to use a key operator, and I'm going to say equal, equal. And I'm going to say player, and I'm going to do left and player right. Now you'll notice that I have a little squiggly here over operator, and it tells me that it requires the matching not equal to be provided. You can't provide one without the other. Unfortunately, the implementation of one of them is pretty straightforward, so I'm just going to do left equal to right and say that if it's not equal, then they're not equal. Now, how do I want to go about implementing my equal? Well, there's various different ways you could do this. You could use the iComparable interfaces to compare things. We're going to keep it pretty straightforward in this example. But what I do want to do is I want to say make sure that the references are equal. If they are, then go ahead and return true, because again, I want to make sure I have the same references do return true. And I also want to say that if left equals null or right equals null, return false. Because clearly if one's null and the other is not, then they're not the equal. But before we continue, what I want to show you real fast is you'll look over here, I see this little icon that's telling me I have a recursive call here. That's because these equal is going to evaluate over and over and over again, because again, I'm on the player, and I'm just implementing the equal, so it's going to cause some issues. So what I need to do to get around that is simply cast it to a base object. And then you'll see that removes my recursive indicator here. Then finally, we know we're not dealing with the same reference, and we know that both of them are non-null. So we want to go about actually inspecting the object to see if they're equal. How do we want to do that? In our example, we're going to say if left.firstName equals right.firstName, and if left.lastName equals right.lastName, and if left.age equals right.age. If all these are equal, then we want to return true. And then finally, if we get down here, let's go ahead and return false because they're clearly not equal. So let's go back and run my test one more time. Now, if I get down on my test and I look at my output again, my first one test is true because they are the same instance. Now, the second one test is true as well because even though they're not the same instance, all the properties are the same. And then finally, my last one fails as expected because they are clearly two different people. Now, that's how you can implement the equal. Now, you could go ahead and take this and just stop listening right now and say, oh, I know how to do all the operators. But in case you want to see how to implement another one, let's do this. We'll create a young player here. We'll call this Albert Pujols, and he's 30. And what we want to do is just say, is young player less than older player? And I'm going to implement the less than or greater than operator. Now, you'll notice immediately I cannot apply the operator less than to these objects. So I need to actually go ahead and implement those. So how do I go about doing that? To implement the less than and greater than operator, you do the same thing. So I create a public static Boolean and use a keyword operator. I'm going to say less than and say player left, player right. And again, if I hover over this, you'll see that it tells me that I need the matching greater than operator to be implemented. And again, down here, what we'll do is say if not less is less than right. So make it simple for us. And then in the less than operator, I don't really care about first name and last name in our example here. What I want to do is make sure their ages are different. So I can simply say return left.age is less than right.age. And if that works, then I should be able to come back to my test and evaluate that indeed the young player is less than the older player. And sure enough, young player is less than the older. If I come down here and look at my output. So in a short time frame, you've taken a look at how we can create operator overloading within our custom objects within .NET. You can see very quickly the power that they could provide, because now you don't need to do a whole lot of comparisons manually. You can just use the operators, and you could of course add the equal, the plus, the minus, the times, the multiplier, the divider, you name it, the operator there for your disposal. In fact, all the operators that you can overload are right here. I'll go ahead and paste this into the example. And you can see that you can overload, I don't know, half dozen or so, or maybe even closer to a dozen. So I hope you learned something, and until next time.